right, so video 1 for level 4 says given A is between C and T, so let's draw ourselves a picture. We don't know where exactly A is. If CA is 4x and AT is 6x plus 12 and CT is 32, we want to find the value of x and the ratio of CA to AT. This brings us back to segment addition postulate. If I take 4x and I add it to the 6x plus 12, that will give me the length of my whole segment, which is 32. Combining like terms, I have a 10x plus a 12 is equal to a 32. Subtracting 12 from both sides, I would get a 10x is equal to a 20. So then dividing by 10 on both sides, I get x is 2. So I found x, that's part of my answer. Now it says find the ratio of CA to AT. So if I put 2 in for x for CA, a 4 times a 2 is an 8. If I put 2 in for x for AT, a 6 times a 2 is a 12, plus a 12 is a 24. A way that you can write ratio, you don't have to write it as, you could write it as a fraction, CA over AT, that's the same thing as CA to AT. And so CA was 8 and AT was 24, and then we can reduce that ratio, and that's going to be a 1 to 3. That's it for that one. All right, number 2 states that we're given B is in between A and C. And the ratio of AB to BC is 2 to 3. And we know that AC is 55, so that's your whole segment. But all we know is that the ratio of AB to BC is 2 to 3. Well, if I label AB then 2x and BC then 3x, the ratio would be 2x over 3x, and the x's cancel out, and that does give me a ratio of 2 to 3. So this works. I can label it 2x and 3x. So then segment addition postulate, if I take that 2x plus that 3x, it gives me the whole segment, which is 55. Or 2x plus a 3x is a 5x, and that equals 55. Dividing by 5 on both sides, x comes out to be 11. Now they asked us for AB and BC, so AB would then be, if I put 11 in for x, AB is 22, and BC, if I put 11 in for x for that, BC is 33. And so if I do the ratio of AB to BC, 22 over 33, I do get 2 to 3. So I am correct on my answer. All right, number 3, M, A, T, H are collinear. That means that it lies on the same line, where point A is going to bisect M, T. So that means that point A is directly in the middle, and MA and AT are congruent. But point T bisects segment AH. So that would mean T is directly in the middle of that, so AT is congruent to TH. And we want to find the value of the ratio of MT to TH. Now, since AT is both congruent to MA and TH, that means that all 3 of these segments are congruent to each other. So if I label MAX, then AT would be X and TH would be X. And so the ratio MT would be 2X, and TH is just an X, or a 1x, and an x divided by an x cancels out, so the ratio is 2 to 1, and that's it. All right, So number 4 and 5 look similar to what we did in level 3. However, it's slightly different. So A, B, and C are collinear, and B is in between A and C, and the ratio of AB to AC is 2 to 5. If we have A at -6, 9, and B at -2, 3, we want to find the coordinates of C. Now, B is in between A and C. So what this means is if we have the coordinates from A to B, we are not finding a point between A and B. We are finding a point past A and B. Unlike where level 3 was us finding a point in between our line segments or our endpoints. So this process is actually going to be different. We want the ratio of AB to AC, so AB would be 2, AC would be 5. So what that means is that point B is 2/5 along this line segment from point A. Okay. So for this is different. Let's find the rise and the run from point A to point B. So my run would be over 1, 2, 3, 4 units to the right, which would be positive 4 units. And my rise would be down 1, 2, 3, 4, 5. So down 5 units would be -5 units. Remember, your run is your X, your rise is your Y value. And I just wrote my rise and my run on this as well, just to show you. But what we did when we found a point in between our line segment is we used our ratio and we multiplied by our rise and our run. This time we're finding a point past our line segment. So actually, we are going to use the ratio instead of 2/5. We are going to use the ratio 5/2. Okay, so C, so we use the reciprocal of the ratio here. So C is 5/2 times your run, which is 4, and then we add it to the X value of point A, which is -6, and then we take the 5/2 and we multiply it by our rise, which I just realized I counted my rise wrong. It's -6. So I multiply my 5/2 by my rise of -6, and I add it to my Y value of point A. So a 5/2 times a 4 plus a -6 gives me an X value of 4. And then a 5/2 times a -6 plus a 9 gives me a Y value of -6. And I'm going to make note that we use the reciprocal in this situation. So for number 5, same thing. I'm finding a point past the line segment. So I have A and B, and I'm trying to find point C, which is past the line segment, not in between. So I want the ratio of AB to BC to be 2 to 5. So that means that B is 2/7 from point A. But if I'm finding the point C, which is past the line segment, we're not going to use the 2/7. We are going to use the 7/2, the reciprocal. Okay. So now, this time I'm not given a graph, so we got to find our rise and our run using our slope formula. So I'm going to label point A, x1, y1, and when we do these types of problems, A needs to be your starting point because B is in between the 2 points. So using my slope formula perfectly, I do y2 minus y1 all over x2 minus x1 minus a negative 6 is really a plus 6. So I wind up with the slope of negative 6, 4, and I do not simplify just like in level 3. And so remember, the denominator represents your run or your x values. The numerator represents your y's or your rise or your change in your y values. And so to find point C, I take my reciprocal ratio, 7/2, and I multiply it by my run, and then I add it to the x value of point A. And for my y, I take my reciprocal ratio, I multiply by my rise, which is negative 6, and I add it to the y value of point A. So simplifying from there, a 7/2 times a 4 plus a negative 6 gives me an 8 for my x value, and a negative 6 times a 7/2 plus a 9 gives me a negative 12 for my y's. All right, so this is your first level 4 video.